Hello students, welcome to Marine Edge. This is your physics tutor Aditi Singh. Today we'll be discussing a guest paper that we have prepared from our end for the upcoming IMU-CET for physics. In our previous lecture, we also covered all the chapters with the help of mind maps of physics. So in case if you want a quick revision, you can check on that. So continuing on, let's get started with the physics. So the first question. Let me take a pen. Okay, all right. Now, the height at which the value of acceleration due to gravity becomes 25% of its value at the surface of Earth's radius. Now, we know that the formula for acceleration due to gravity g dash is equals to g r divided by r plus h. Let's say h is the height at which the acceleration due to gravity will become 25%. This is the formula. So now as we can see that the final gravity is 1 by 4. So if we just take this g here, so g dash by g, that is equal to 1 by 4, is equals to r square by r plus h, correct? Now, the whole square, sorry. Let's write it like this, r square by r plus h, right? So, we can write it as 1 by 2 equals r upon r plus h. So, that gives us what? 2r equals r plus h. So that gives us r is equals to h, right? So at height h is equals to r, the gravitational field will become 25% of what it is initially at the surface of Earth, right? Now moving forward. A body of mass 2 kg moving with the velocity of 10 meters collides in a head-on collision with another body of mass 2 kg at rest. Now as we can see, both masses m1 and m2 are equal, right? That is 2 kgs. And it is a perfectly elastic collision. So there is no loss of kinetic energy. So whatever initial energy was in the body, first body, that will get completely transferred to the second body. So after the collision, the velocity of the first body will become 0 and the velocity of second body will become 10. Okay. Now, next, escape velocity from Earth's surface is 11.2 km per second. The escape velocity from a planet whose mass and radius are both twice that of Earth will be. So we know that the formula for escape velocity VE is equals to under root 2 gm upon r, where r is the radius of whichever planet we're talking about. Now, if mass also, so for this secondary planet, the escape velocity will be equal to under root 2 into mass will also become twice, and the radius of the planet is also becoming twice. So in the end, we are receiving the same value. So the final answer will be again same as initial value, that is that will be the escape velocity of Earth only, that is 11.2 kilometers per second, right? Now, next, a force F is equal 3I cap plus 4J cap plus 5K cap, minus 5K cap. Acts on a body. It is asking for the magnitude of the force. So basically it is a vector question. It is asking for the magnitude of the vector. So what is the formula? The formula is we just square all these three values and take the under root of it. So 3 square plus 4 square plus 5 square. That will give us what? Under root 9 plus 16 plus 25. So that is 5 root 2. Now suppose the question would have asked you about the unit vector. So you could have just divided this vector by 5.2 to give the unit vector, right? Now moving forward, a ball is thrown vertically upward with the velocity of 20 meters per second. So initial velocity is 20. The maximum height reached it. So see, initial velocity is 20. At maximum height, the velocity of ball will be 0, right? So V is 0. And so S is equals to, V square is equals to U square plus 2AS, right? And A, or the acceleration in this case, will be gravity acting in opposite direction, right? Gravity is acting in downward direction. So for that, 0 is equals to 20 to the square plus 2 into minus 10, let's take for gravity. Yeah, it's given already here. If it is not given in the question, you can take 9.8 as well as 10, whichever suits the answer, okay? And if both answers are also available, in that case, always ensure taking 9.8 and S. So what do we get? 400 is equals to 2 into 10. So that gives us maximum height as 20, right? Next. Now, moment of inertia of a solid spare mass m and radius r about its diameter. What is the formula for moment of inertia? 2mr square upon 5, right? about its diameter. So these are some of the formulas that you must be remembering in your exam hall, right? Now, a wheel of mass 10 kg has a moment of inertia of 160 kg meter square about its own axis. What is the radius of gyration? So what is the formula for radius of gyration? The radius of let's say, okay, this is not working, right? So the formula for radius of gyration k is equals to under root I upon m, correct? So value of I is given to us 160, mass is also given to us 10. So we cancel it out, you will get your answer as 4 meters, correct? Now, a particle performing uniform circular motion has an angular momentum L. So angular momentum is given to us as L. Its angular frequency is doubled and kinetic energy is halved. So omega is doubled, omega becomes 2 omega, and kinetic energy becomes 1 by 2. So what will be its new angular momentum? So as we know, kinetic energy for a circular motion is equals to 1 by 2 I omega square, correct? So what can we say? Can we say that K is equals to 1 by 2 L omega, because we know that L is equals to I omega, right? So using this equation, we can write Ke upon omega is proportional to L, right? Kinetic energy upon omega is proportional to L. Now, as the question suggests, kinetic energy is become 1 by 2. So I'll just solve it here itself. So Ke has become 1 by 2. So now for this new value of angular momentum, we have 1 by 2 Ke and 2 omega. So now the final angular momentum becomes 1 by 4 times whatever was the initial value of angular momentum, right? So it becomes L by 4. Now moving forward, two circular discs A and B have equal masses and equal thickness, but density D1 and D2, density is different, right? D1 is greater than D2. Now, if two objects have same mass and same thickness, and if if one object is denser than the other object, in that case, what will happen? What is the formula for density? How do we calculate density? Density is equals to mass per unit volume, right? So, if density of D1 is greater than density of D2, in that case, and the mass is same. So, in that case, volume 1 will be greater than volume 2, right? Now, moving forward, we have two circular discs A and B having equal masses and equal thickness, but density D1 and D2 are different of the two objects, okay? And D1 is greater than D2. Now, if D1 is greater than D2, in that case, what will happen? Density and volume are, we know that density is equals to mass per unit volume. So, if density is high, volume will be low. So, V1 will be less than V2, correct? And if volume is less for any disk, what is volume? Volume is 2 pi r, right? Volume will be dependent upon the radius into h, whatever is the height of the disk, correct? So height is same for both. So what can differ? 2 pi r, 1 h1 and r2 h2, right? So if we already know height is same for both the cases, radius r1 will be less than r2, right? And what is the moment of inertia of a disk? Moment of inertia of a disk is 1 by 2 mr square, right? Mass in both the cases are same. So if R1 is less than R2, IA will be less than IB, correct? Now, moving on, torque per unit of moment of inertia. So torque per unit I, what is it called? We know that torque is equals to I alpha, right? So torque per unit I will be alpha, that is angular acceleration. Moving on. Equation of displacement of a harmonic acceleration is 3 sine omega t plus 4 cos omega t. What will be the amplitude? Just take the magnitude of these two values and square it. 3 square plus 4 square, right? And you will get your answer as pi. That is the amplitude. Now, in an SHM, when displacement is half the amplitude, the ratio of kinetic energy to potential energy is? So, what is the formula for potential energy? Half kx square. And what is the total energy of any SHM? That is 1 by 2 Ka square, correct? Now, it is given that at this point, kinetic energy is half the potential energy. Sorry, the amplitude is half the amplitude. So, the value of x is A by 2, correct? So, in that case, the potential energy, and this is the total energy, right? So, the potential energy will be 1 by 2 K into a square by 4, correct? Now, this will be the value of potential energy, and we know that kinetic energy is equals to total energy minus potential energy. So, 1 by 2 Ka square minus Ka square upon 8. So, that will give us what? 3 by 8 Ka square. That is equals to your kinetic energy, right? So, the ratio of kinetic energy is 3 by 8, and here we have 1 by 8 K square. So, that is 3:1, correct? Moving on. A spring of force constant K is cut into 3 equal parts. So, whenever we have a spring, and if we are cutting into 3 equal parts, now the shortest spring will be spring will be more stiff, right? It will have more restoration force. So, each string gets divided into each string has its own spring constant becomes 3 times what was the initial value. Okay, so it becomes 3K. Now, moving on, the load of 10 grams increases the length of a light spring by 10 centimeters, and we have to calculate the spring constant. Now, if we are saying that because of this weight, the spring got elongated by 10 centimeters, so this F is equals to Kx, and X is equals to 10, right? Now, and because of this weight, the weight is 10 grams. So, we know that weight F is equals to mg, right? So, mass is 100 and g is 9.8. That will be equal to Kx. And X we already know is 10, correct? Now, if we take all of this in standard units, we'll convert this 10 into mm and this 10 grams into kg. So, K will become, this K becomes 10 in, K into 0.01 is equals to 0.1 into 9.8, right? Sorry, this will not be 0.1. This will also be 0.1. 0.1. So this and this gets cancelled and you get the value of K as 9.8. That is option A. Okay. Now moving on. If the length of a simple pendulum is increased 4 folds, what is the time period? Now, what is the time period of a simple pendulum? 2 pi under root L upon G. Now, if length increases by 4 times, so the new time period will be what? 2 pi into 4L upon G. So that is, and once this 4 comes out of the root, that time we will get 2 into initial time period, right? This 4 will come out and get multiplied by 2. So we get 2 into initial time period, that is 2t. Now, a hollow copper sphere is given a positive charge. The electric field inside the sphere is, so we have already discussed, inside a hollow sphere, there is no electric field here, right? Outside you will feel it. In a solid sphere, there will be electric field inside the sphere, but in a hollow shell structure, there is no electric field inside it, okay? So that will be 0. Now, a charge Q is enclosed by a Gaussian spherical surface. So there is a spherical surface and there is a charge Q inside it, okay? Of R. If the radius is doubled, the outward electric flux through the surface. Now, even if we increase the radius to double, the charge enclosed by this Gaussian surface is still Q. So, that remains the same. Now, when the capacitors C1, C2 and C3 are connected in parallel, the formula for equivalent capacitance will be just normally, for the capacitors, we just normally add it in parallel. So, it will be C1 plus C2 plus C3, right? The potential of two plates of a capacitor are plus 10 volts and minus 10 volts. What is the potential difference between them? So first plate has 10 volts minus the potential of the second plate, that is minus 10 volts. The total potential difference will be 20 volts, right? So option C. Now, an electric field can affect, what can it affect? So first, X-rays, they have no charge, so it cannot affect that. Neutrons, they are neutral already, no charge. Gamma rays also have no charge. So what are we left with? Cathode ray. Cathode ray is a string of electrons. Okay. So these are negatively charged. So only charged particles can get affected by electric field, right? So our option is cathode ray. Now, a convex lens of focal length 40 centimeter is in contact with a concave lens of focal length 25 centimeter. So what will be the power of the combination? So for the convex lens, convex lens have positive focus. So power here, the power 1 of a convex lens will be 1 by 40. We convert this centimeter to meter, right? So that will become 0.4. And the power of the second lens, since it is a concave lens, the power will, since the focal length is negative, the power will also be negative. That is 1 upon 0.25, right? Now this and this 25, so you get 4, and here 4, so 2.5. Now what will be the final power? 1.5. So option B, right? Now the critical angle is maximum when the light travels from, so this happens whenever the ratio between the density or the of the two forms is almost equal to 1. In that case, the critical angle is maximum. So that will be in the case of glass to wood. Okay. When light travels from one medium to another, the characteristic that does not change is, see, when light travels, speed also gets affected because of the medium. So if there is a denser medium, speed will be less. If it is a rarer medium, speed will be more. Wavelength is also dependent upon the medium. And amplitude of how fast or how high or low the wave size will be, that also depends upon the medium. But what does not depend upon the medium is the frequency. So frequency remains unchanged. Next. An object lies 1 meter in front of the mirror. The mirror moves 10 centimeter towards the object. So we have an object. We have a mirror, and in front, in 1 meter away from it, we have an object. So image will be formed here. So this will also be 1 meter. This will also be 1 meter. Now the mirror moves 10 centimeter towards the object. So the mirror was moved here, right? This, let's say, is 1 centimeter. Now the new distance between the object and the image will be, so now this distance left is 0.9 meters, correct? So image also here will be formed at distance 0.9 meters. So the distance between object and image will be 0.9 into 2, that is 1.8. Now, optical fibers, what principle does it work on? So optical fibers are wires like this. They work on the principle of total internal reflection. So waves are sent, and they are made in such order that the whatever reflection of waves happen, the whole reflection gets reflected inside the system only. Okay, the critical angle is, the angle of reflection is more than the critical angle. So optical fibers works on the principle of TIR. Okay, now moving on. The source and the sink temperature of a Carnot engine are 40 Kelvin and 400 Kelvin and 300 Kelvin. Okay, it is asking for the efficiency. So what is the formula for efficiency? The mu is equals to 1 minus the temperature of the sink, that is temperature of the sink, that is 300, divided by temperature of the source, that is 400. So that will give you 1 by 4, that is 25%, right? So option B. Now, moving forward, a gram of water at 100 degrees Celsius and converted into steam at 100 degrees Celsius. So what amount of heat is required? This is asking about latent heat of fusion, of vaporization. Okay. Now this can only be solved if you are already aware of the answer, that is, you have already come across this question. So because you have to remember the value of latent heat of water. Okay, that is 540 Kelvin. Now, a sound wave has a frequency of 2 Hertz and a wavelength of 35 centimeter. An observer is 1.4 kilometer away. After what time will the observer hear the sound? So the speed of the sound will be what? Frequency into wave lambda, right? Frequency into lambda, or the wavelength. So frequency is given towards as 2 kilohertz, 2 into 10 to the power 3, and the wavelength is 35 divided by 100, right? It is given in centimeters, so we'll convert it into meters. So that gives us a value of what? 35 into 2 into the power 700 meter per second. Now the observer is at 1.4 kilometer away. So what will be the time taken? 2 seconds, right? So the answer is B. The ratio of excess pressure inside two soap bubbles with radii of ratio 2:1 is, what is the value of excess pressure inside a bubble? That is 2T upon R, right? So if the ratio of the pressure, the ratio of the radii is 2:1, what will be the ratio of pressure? Since the pressure is inversely proportional to radius, so the ratio of the pressure will be 1:2, correct? So answer is A. Now, moving on. A body of mass 50 kg has a velocity reduced from 20 meters to 5 meters by a restoring force in 5 seconds. So initial velocity was 20, final velocity is 5, and time period is also 5 seconds. So it is asking about the magnitude of the restoring force. So acceleration will be what? 5 minus 20 upon 5, that is 3 meter per second square, minus 3 meter per second square to be specific. Now, and the mass is also given to us, that is 50 kg. So, what is the force? Force is equals to mass into acceleration. That is 50 into 3. So, 50 into 3, that will give you 150. Now, here we are not taking the negative sign because it is already mentioning it is a resisting force. So, we already know it is a negative sign. So, instead we have taken it as just 3. Okay. And the force is 150 newtons. Now, apparent frequency heard by a listener moving away from a stationary source is 10% less than the actual frequency. Now, if the speed of the sound is 330 meters, what is the velocity of the listener? So, the frequency of a moving, when the observer is moving, is equals to what? Is equals to f upon velocity of the sound minus velocity of the observer divided by velocity of the sound, right? Now, we can say that it is already mentioning that the frequency heard by the listener is 10% less. So, the final frequency is 0.9 times the initial frequency. So, can we write f dash upon f is equals to 0.9? Now, if we take this f downside, 0.9 is equals to v 1 minus v naught upon v, correct? So, now, v naught is the velocity of observer, v is the speed of sound, that is already given to us 330, right? So, 0.9 is equals to 1 minus v naught upon 330, correct? Now, let's solve it out. So, 330 into 0.9 is equals to 330 minus v naught, correct? Now, if you multiply these two values, you will get 297 is equals to 330 minus v naught. So, you'll get the value of v naught is equals to 33 meter per second. That is your option A. Now, moving forward, a constant wire is used in making a standard resistance because see, resistance is mostly dependent upon the only non-moving factor of a resistance is the resistivity, that is rho L upon A. This is a constant for different types of element, and the only thing that influences this resistance is your temperature. For a constant wire, the temperature coefficient of resistance, it is negligible. So, it will not be affected by changing temperatures. That is why it is used to make standard resistance. Okay. Now, drift velocity of electron in the conductor. So, this also you cannot be knowing, you cannot be solving it in the exam. Drift, you will have to go through some similar kind of questions to actually know that the drift velocity of electrons in a conductor is of the order 10 to the power 4 or even 10 to the power minus 3 also. So, if in that same range. Okay. Now, unit of specific resistance is, what is specific resistance? This value of ohm. Okay. So, if you know R is equals to rho L upon A, so that is ohm is equals to the value of whatever will be of rho. L is length is in meter and area is in meter square. Correct? So, rho will be ohm meter. So, option B. Okay. Now, moving on. Wheatstone bridge is given to us P1Q, PQRNS. Okay. And it is saying that the bridge is not balanced. So, how do we balance it? So, P upon Q should be equal to R upon S. Right? So, what is the ratio? P upon Q is 10 upon 5. That is not equal to 4 upon 4. Right? So, how can we balance it out? If we add another 5 ohm resistance to this Q, these two also will cancel out to give 1, right? So, we can add 5 ohm in series with Q. So, option D. Okay. Now, a potentiometer measures potential more accurately because here measures potential in closed circuit? No. Uses high galvanometer sensitivity? No. Measures potential in open circuit at null point. See, whenever we measure potential because of with using a potentiometer, we try to make a Wheatstone bridge out of it, right? So whenever there is whenever it actually pinpoints the actual potential of a device, at that point there is no current flowing through it, right? It calculates at null point. So because of that, it does not consume any part of the potential. So it gives a more exact reading out of it. Now, moving on. The word magnetism is derived from iron ore called magnetite. Okay. A jet craft flies due south at 300 meter per second. So, velocity is 300. Where the vertical component of Earth's magnetic field is 80 microtesla. Okay. So, the value of B is 80 into 10 to the power minus 6. And the wingspan length is 25 meters. So how much EMF will be induced? The value of induced EMF is what? V into L cross V. So the 80 into 300 into 25. If you multiply all of that, 80 into 25 into 300 into 10 to the power minus 6, you'll get the value as 0.6 volts. So option B. Okay. Now, two pure inductors, each of self-inductance L, are connected in parallel, far apart. What will be the total inductance? So when inductors are connected in parallel, to calculate total inductance, what do? 1 by L1 plus 1 by L2, right? So, 1 by L plus 1 by L, that is 2 by L is equals to 1 by L equivalent. So, L equivalence becomes L by 2. So, correct option is C. An inflated balloon with a heavy rock sinks in water. As it sinks, the buoyant force, so see, this is a tank in which we have a balloon, and this balloon is going down. As it will start going down, what will happen? The pressure will keep on increasing on the balloon. Now, we know that PV is equals to constant, right? By Boyle's law, we know that. So, if pressure is increasing, volume will start to decrease, right? So, if volume of the balloon will start decreasing, because there's gas inside the balloon, right? So, that if it starts decreasing, so the amount of water this balloon will be displacing will also start decreasing, right? So, and buoyant force is dependent upon what? The amount of water the object is displacing. So, if the volume of the displaced volume is reducing, the buoyant force also will reduce, right? So, that is why the buoyant force decreases. Now, in a Carnot cycle, when heat is absorbed from a hot source by working gas, what happens? This process will include isothermal expansion. So, what it happens is, let's say that we have a piston, for a random example, okay? Now, this piston is compressing gas, okay? Sorry, not compressing, expanding gas. So, for expansion to happen, if the expansion happens by the work done of this gas, so there's gas inside, this gas is trying to push the piston, so the piston moved here, okay? So because of that, what will happen? The temperature will drop down because the gas expanded, right? But from the source from the heat source, we are constantly supplying heat to maintain the temperature of this gas. So the temperature is remaining constant, but expansion is also happening. So it is isothermal expansion, okay? Now, the value of retarding potential needed to stop a photoelectric induction from a metal with work function 1.2 electron volts and light of energy 2 electron volts will be. So we know that the formula is Ke is equals to Hv minus pi, okay? The value of Hv, or the energy, or we can also write it as Ke is equals to E minus phi. So it is already given to us, the energy is 2 electron volts and the work function phi is 1.2, right? So if we subtract 2 minus 1.2, you will get what? 0.8 volts. That is your option C, correct? Now, moving forward. According to Bohr's atomic model, the electrons revolves in orbits where, according to Bohr's model, it was given that MVR, or the electrons will only revolve in orbits which have the energy equals to NH upon 2 pi, right? So it can only revolve in orbits which are multiple of H upon 2 pi. So that is your option B. Okay. Binary representation of decimal 45. Now how can we write 45? 45 is equals to 32 plus 8 plus 4 plus 1, that is 2 to the power 5 plus 2 to the power 3 plus 2 to the power 2 plus 2 to the power 0, right? So we have 0, 1, 2, 3, 4, 5. This will become 1, 0, 1, 1, 0, 1. So 1, 0, 1, 1, 0, 1. 1, 0, 1, 1, 0, 1. That is your option B. Next. Decimal representation of 1, 0, 1, 1 will be, so 2 to the power 0 plus 2 to the power 1 plus 2 to the power 3, right? Because 2 to the power 2 is already 0. So 1 plus 2 plus 8. So we'll get the answer as 11. So option C is correct here. Now, 4 colored metallic articles at the same temperature are allowed to cool. Which will cool fastest? So we have blue, red, black, white. Now see, black body is the fastest to cool, right? Because it emits all the heat. So it will cool the fastest. Now, resistance of a wire of diameter 6 mm is 5 ohm. If it is drawn until diameter becomes 3 mm, what will be its new resistance? Now, if the diameter has been reduced from 6 mm to 3 mm, that is halved, what will happen? So we know that resistance is inversely proportional to 1 upon area square, right? And now if diameter has become half, the radius will also would have become half. So the resistance is proportional to 1 by 4 times the diameter ka square or radius ka square, correct? Now, not square, actually it should be power 4, right? Because area is 2 pi r square, sorry, pi r square, right? Now, so the resistance is proportional to the power of 4 of diameter or radius, right? Now, if diameter has become half, so that means r dash is equals to 1 by d upon 2 to the power 4. So 2 to the 16. So r dash is equals to 16 times whatever the value of r was, right? So r was already 5. 5 into 16, you will get your answer as 80. Okay. A elastic spring has a spring constant K. When it is cut into 3 equal parts and all 3 parts are connected in parallel, what will be the effective force constant? Now, as we discussed before, if the spring is cut into 3 equal parts, each part will have a spring constant of 3K. Now, if we are attaching these 3 springs in parallel combination, what will happen? We'll just add all the 3 spring constants, 3K plus 3K plus 3K, and you get finally as 9K. So 9K is the spring constant of the new spring setup. A body executing SHM with an amplitude of 0.1 meter. At what displacement from the mean position is the potential energy equal to kinetic energy? Now, potential energy is equals to kinetic energy at x is equals to amplitude upon under root 2. This either you will be knowing or you can also derive it. Okay, so what you can do is, one second. Okay, this is not working. Anyway, so I'll show you with an example here. Now, so kinetic energy of a spring is one potential energy, total energy minus potential energy, correct? And we know that potential energy is equals to half kx square, and total energy is equals to 1 by 2 k a square, correct? Now, so kinetic energy will be what? 1 by 2 k a square minus 1 by 2 kx square. This should be equal to, so that will be equal to your kinetic energy, right? And this kinetic energy should be equal to the potential energy at that point of time. So 1 by 2 kx square. So if we just take it to the other side, 1 by 2 k a square is equals to kx square. K and k will get cancelled, and a square upon 2 is equals to x square. So that implies x is equals to a upon under root 2. So at x, at the displacement amplitude upon under root 2, at that point the kinetic energy and potential energy will be equal. So now in the question we have been given amplitude is 0.1 divided by under root 2. So that you will get, just multiply the whole thing by under root 2 into under root 2, and you will get 0.1 by 2 into under root 2. That is 0.05 under root 2. So option C. Okay, sorry. Option C. Okay. Moving on. A boat crosses a river with velocity of 8 km relative to water. If the resultant velocity is 10, what is the velocity of river? So if the resultant velocity is 10, that would be equal to the velocity of boat plus the velocity of river. So if you just take the amplitude square of, this is the resultant velocity is 10, velocity of river is given as 8, the square of 8, and velocity of current. And we have to find out the velocity of the river, that is, let's say x ka square. Okay. So we'll just take 100 is equals to 8 square plus x square. So 36 is equals to x square. So that implies velocity of the river x is 6 kilometers per hour. That is your option B. Lastly, if a Carnot engine operates at the source temperature of 127 degrees Celsius and a sink temperature of 27 degrees Celsius, what will be its efficiency? Now, to calculate that, convert these two into your Kelvin scale. So 127 plus 273, that is 0, 0, 400. And 27 plus 273, that will give you another 0, 0 and 300. Isn't it the same question as we first solved? So that will be 1 minus 300 by 400. That is giving you 1 upon 4. That is 25%. Right? So that was about it with this guest paper. I hope you are well prepared for your upcoming exams. and try solving as much as questions at this point of time. Try going through PYQs and all the necessary, and the more you practice at this point of time, that will be better for you. So stick to solving more and more questions at this point. Try different types of question, guys. Okay, all the best for your exams. Thank you, students.